everyone. We are the group number 1, and the members of my group are Michael Marquez, Michael Arellano, Stephanie Rivera, and my person Cecilia Leon. And today we are going to talk about a pressure system for water supply. To start, we need to know that these systems help bring water to buildings in an efficient way. The first system is the direct pressure system. This is uses the water pressure from the public supply, and it is simple, but can we change in the public water pressure change? And the second system is the pump and pressure tank system. Here, these systems pushes the water into the tank, where it's stored under pressure until we need. And finally, there is the variable speed pump system. This system is more efficient, but it depends if this change by the pump speed based on how much water we need. And there are also different types of pumps, like centrifugal pumps. This is so common. Positive displacement pumps. This is for more control, and the summer pumps. This is used just for depth water. We know that choosing the right system depends on the size of the water network and how much water we need.
What needs to be considered for the impulsion and suction? First, we need to talk about the intake structure. It needs to be designed to prevent the entry of air, dirt, or any other contaminant that could damage the pump or that could disrupt the flow of the water. Then, the pump must be selected and placed. It needs to be done in order to increase efficiency. For that, we need to consider some factors like the depth of the water source and the flow rate requirements. Then, about the pipes, factors as pipe material has to be considered to minimize friction losses and the pressure drop. And finally, the air. Air trapped in the system can reduce its efficiency, so air release valves needs to be installed at all high points of the pipe distribution system.
The primary types of pumps in water supply pressure system include centrifugal pumps. For the first, we have advantage like simple design, low maintenance, efficient for large volumes of water. This advantage is ineffective at high pressure, performance drop when flow changes. Positive displacement pumps. Advantage provides a steady flow regardless of pressure, ideal for high pressure needs. Disadvantage is more complex, higher maintenance, sensitive to change in fluid properties. The last is the booster pumps. Advantage effective for increasing pressure in low pressure systems. Can be installed without altering the main system displays. And the last disadvantage is requires additional equipment and energy, adding complexity. That's all.
Hi, my name is Michael, and we talk about how to calculate pump power or how to select the pump model. First, we have to calculate the pump power through this formula, as we can see in the number 1. As second, we have to determine the flow water, the flow rate, or the flow demand. Include some factors like process requirement of water, using equipment, diameter and length of pipes, etc. A third, we have to determine the head, because it's important to select a pump model. A fourth, select the model following some considerations like the flow rate and head should meet the requirement of use, the material and structure of the pump should meet the requirements, and of course, the price and maintenance cost should be reasonable. We have an example of pump power calculation or what could be a pump models selected. Suppose a fountain land space need a pump of water supply. The flow rate is 10 meters cubic per hour. The head is 40 meters, and the pump efficiency is 70%. First, we have to calculate the output power of the pump. As we can see, is 3.9. And second, we could calculate the input power of the pump. That includes the efficiency of the pump. And finally, we could select the appropriate pump model. There are some manuals where we can select the pump model through the power or through the head. In this case, we could calculate, or we could select an appropriate pump model through the demand and the head. As we can see, we could transfer 10 meters cubic per hour for a gallon per minute. And through this graphic, we could select the current model, that is this one, the first one. We have to select the upper of this point. That will connect this point, and that's all. Thank you.